but since there's so much information around COVID-19 on Twitter, it's difficult to separate facts from fiction. So you can imagine if something which is not factually correct is posted on in Twitter with certain URLs or information news links, and if it goes viral, then we have to like mitigate it beforehand from stopping it from getting viral, right? So the problem statement we're trying to tackle is like, if someone posts a URL on Twitter, then we try to predict its virality using its initial presence in the data. And then if something is going to go viral, we can let the authorities know to like do fact checking. Yep. So as you know, we are working on Twitter data. So we hydrated like a bunch of tweets. So we had like initially 2.1 billion tweets for 3 years worth of data. But we for this POC, we are using like 1 month data, which has like 200K tweets coming out from United States related to COVID-19 and had a URL which was mentioned along with the tweet. So we extracted like hashtags, URL, the metadata, and all the text information of the tweet, and how many followers does the person has, how many times it were retweeted, and all this information. So we have like 200K tweets, 98,000 users, 11,000 URLs, and around 11,000 unique hashtags in the data we are using. So we did a lot of complex feature engineering. So a tweet has like two types of information. One is like the hashtags associated with it, and another is like the text itself. So on the text, we are doing like topic modeling to extract the theme of the text using the entire data. Then we extract the sentiment score. Then we have like a 11-dimension emotion extraction. Like within the tweet, the text depicts like whether a person is happy, sad, angry, depressed, and all those kind of like detailed depiction of how a person feels about. And then a stance detection. So we have a statement called like COVID-19 is dangerous. So how is the statement related to this particular statement? So it could be like contradiction, entailment, or a neutral score. So we have all those vectors. And then we represent this text in form of embedding so that we can later use it. And then for the hashtag, we just have like a bag of word representation so that we can numerically use it later on. So we have like all these vector features in our data, which kind of are at a tweet level. So, but since we are going to create everything as a user level, so we try to roll up all these features at a user level. So we take like a mean of emotion score, sum of hashtag, and mean of the topic theme to get the same kind of features at a user level. So now every user has a emotion score, vector topping score, and hashtag score, and also of course some raw features like how many followers does this person has, because it also has a relation to if he has an impact on social media or not, right? If someone has more followers, it's likely that someone he post has more visibility in the data. So once we have all these user level features, the next task is to connect these users in the graph. So the obvious choice could have been to use the follower information, like who follows whom, but that is very difficult to extract because the Twitter API has very limited requests. So what we thought of is like we could use a proxy, like using all these vector representations. We can run like a k-nearest neighbor to identify who are like likely connected to another people in the data based on what they feel about. So using like a weighted matrix, we created a directed graph. So we have like a matrix of like who is connected to whom. And of course, in the graph, we have features like how many followers does a person has, what is the vector representation of a user, and edge features are like what is the cosine score of when two nodes are connected to one another, and what is the Euclidean distance. And a graph label is like what is the retweet count of a URL. So let's talk about like how these graphs are created. So if you have like 11,000 URLs in the data, then you get like 11,000 instances of training data, because for every URL, we just see that who tweeted that URL or retweeted that. So those nodes get activated, and then we try to train a graph level prediction task that this is a retweet count. And then on the test data, like using first 3 weeks as training and last 1 week as test, we just try to evaluate like the performance of the graph neural network model. So right now we are training the model because this is a very giant graph of like 100K nodes with so many edges, and then it is getting trained. So next step is like once we have this graph training done, we'll just have a LSTM layer to do a forecasting process on top of that, and then identify like which nodes had an influence on making certain URL very viral or not getting viral, something like that. So the next task, the ultimate task, is to do the causal analysis on like if we can draw some conclusions out of these representations with respect to COVID-19 incidence data. Thank you.